Question 1. The investigation demonstrates that a proposed change to the NSX data center's distributed firewall rules is intended to streamline network segmentation for a new application deployment. However, the proposed changes could potentially alter traffic flow for existing critical services. Which of the following approaches best addresses the potential impact of this change on the overall security posture and operational stability of the NSX environment? Option A. Focus the impact assessment solely on the network connectivity requirements for the new application, as the existing services are already functioning correctly. Option B. Document the proposed firewall rule changes and proceed with implementation, deferring any detailed analysis of potential impacts until after the new application is live. Option C. Conduct a comprehensive impact assessment that analyzes the proposed firewall rule changes against existing security policies, identifies potential conflicts or unintended consequences for both the new application and existing services, and includes a rollback plan. Option D. Immediately implement the proposed firewall rule changes to facilitate the rapid deployment of the new application, assuming that any issues will be addressed reactively. Correct answer is C. Conduct a comprehensive impact assessment that analyzes the proposed firewall rule changes against existing security policies, identifies potential conflicts or unintended consequences for both the new application and existing services, and includes a rollback plan. Explanation. This scenario presents a professional challenge because it requires a network administrator to assess the potential impact of a proposed NSX data center configuration change on existing security policies and operational performance. The challenge lies in balancing the benefits of the new configuration with the risks of unintended consequences, such as security vulnerabilities or performance degradation, which could violate regulatory compliance or impact business continuity. Careful judgment is required to ensure that all relevant factors are considered before implementation. The correct approach represents best professional practice because it involves a systematic and thorough impact assessment. This includes identifying all affected components, analyzing potential risks to security and performance, and developing mitigation strategies. This aligns with the principles of responsible IT management and adherence to best practices for network security and operational stability, which are implicitly expected within professional IT environments governed by general IT governance frameworks that prioritize risk management and due diligence. An incorrect approach that focuses solely on the technical implementation without considering security implications would be professionally unacceptable. This failure could lead to the introduction of security vulnerabilities, potentially violating data protection regulations or industry-specific security standards. Another incorrect approach that prioritizes speed of deployment over thorough testing could result in performance issues or service disruptions, impacting business operations and potentially leading to non-compliance with service-level agreements or operational mandates. A third incorrect approach that neglects to document the assessment and proposed changes would hinder future audits and troubleshooting, demonstrating a lack of professional diligence and transparency. Professionals should employ a decision-making framework that begins with a clear understanding of the proposed change and its objectives. This should be followed by a comprehensive risk assessment, considering technical, security, and operational impacts. The next step involves evaluating potential mitigation strategies and their feasibility. Finally, a documented plan, including rollback procedures, should be established before proceeding with any changes. This structured approach ensures that decisions are informed, risks are managed, and compliance is maintained. Question 2. System analysis indicates a requirement to troubleshoot network performance issues within a VMware NSX data center environment that handles sensitive customer data. The primary concern is to gain visibility into network traffic without violating data privacy regulations and compliance mandates. Which of the following approaches best aligns with regulatory compliance and professional best practices for network troubleshooting in this context? Option A. Enable full packet capture on all network segments and interfaces within the NSX environment to gather comprehensive diagnostic data for immediate analysis. Option B. Configure NSX to bypass all security policies for troubleshooting purposes, allowing direct access to packet payloads for all network flows. Option C. Implement NSX's distributed firewall logging to capture detailed session information, and then use a secure, authorized process to export and analyze these logs in an isolated, compliant environment. Option D. Utilize NSX's traffic mirroring feature to send all network traffic to an unmanaged, publicly accessible analysis server for real-time inspection. The correct answer is C. Implement NSX's distributed firewall logging to capture detailed session information, and then use a secure, authorized process to export and analyze these logs in an isolated, compliant environment. Explanation: scenario analysis. This scenario presents a common challenge in cloud networking environments where security and compliance are paramount. The professional must balance the need for network visibility and troubleshooting with the strict requirements of data privacy and regulatory adherence. The challenge lies in identifying and implementing a solution that provides the necessary diagnostic capabilities without inadvertently exposing sensitive data or violating compliance mandates, particularly concerning data in transit. The complexity is amplified by the distributed nature of NSXD and the potential for diverse data flows across different network segments. Correct approach analysis. The correct approach involves leveraging NSXD's native capabilities for traffic mirroring or packet capture in a manner that is compliant with regulatory frameworks. This typically means ensuring that any captured or mirrored traffic is either anonymized, encrypted, or restricted to specific, authorized personnel and environments. For example, using NSXD's built-in packet capture features, and then securely transferring the data to an isolated analysis environment, or employing traffic mirroring to a dedicated security monitoring tool that is itself compliant, represents best professional practice. This aligns with regulatory principles that mandate data protection and restrict access to sensitive information. The key is to ensure that the method of obtaining visibility does not create new compliance risks. Incorrect approaches analysis. An incorrect approach would be to indiscriminately enable full packet capture on all network segments without considering the data content or regulatory implications. This could lead to the capture of sensitive personal data, financial information, or other regulated data types, thereby violating data privacy laws and compliance standards. Another incorrect approach would be to rely on third-party tools that are not certified or validated for compliance with the relevant regulatory framework, as this introduces an unknown risk factor and potential for non-compliance. Furthermore, attempting to bypass or disable security controls to gain access to traffic for analysis would be a severe ethical and regulatory violation, as it undermines the very security posture that compliance frameworks aim to enforce. Professional reasoning. Professionals must adopt a risk-based approach. Before implementing any network visibility or troubleshooting solution, they should 1. Identify the specific regulatory requirements applicable to the data being processed and transmitted within the NSXD environment. 2. Assess the potential impact of traffic capture or mirroring on data privacy and security. 3. Select NSXD features or integrated solutions that offer granular control over data visibility and access. 4. Ensure that any data collected is handled, stored, and analyzed in a manner that is fully compliant with all relevant regulations. 5. Document all decisions and configurations related to network visibility for audit purposes. Question 3. Examination of the data shows that a large enterprise is undergoing a significant expansion of its NSXD data center deployment, requiring the implementation of granular network segmentation for newly provisioned workloads. The primary objective is to ensure that sensitive data remains isolated and protected, adhering to strict internal security policies and relevant industry compliance standards. The IT security team is evaluating different strategies for deploying and managing these segmentation policies across a hybrid cloud environment. Option A. Manually configure distributed firewall rules on each individual NSXD host and edge node based on ad hoc requests from application teams, without a centralized policy repository or automated validation process. Option B. Implement security policies as code using declarative configuration management tools, integrating them into a CI/CD pipeline for automated deployment and validation of distributed firewall rules across all NSXD segments. Option C. Deploy network segmentation without a formal, documented security policy framework, and without establishing a process for regular review and auditing of the implemented segmentation rules. Option D. Rely solely on host-based firewalls on the individual virtual machines for network segmentation, disabling or minimizing the use of NSX distributed firewall capabilities. The correct answer is B. Implement security policies as code using declarative configuration management tools, integrating them into a CI/CD pipeline for automated deployment and validation of distributed firewall rules across all NSX segments. Explanation: scenario analysis. This scenario presents a common implementation challenge in large-scale NSX deployments, ensuring consistent and secure network segmentation across a distributed environment while adhering to evolving security policies. The challenge lies in the potential for misconfigurations during a significant network change, which could lead to unintended access, data breaches, or service disruptions. The need for a robust, automated, and auditable solution is paramount to mitigate these risks and maintain compliance. Correct approach analysis. The correct approach leverages NSX's distributed firewall capabilities and its integration with automation tools. By defining security policies as code and deploying them through an automated pipeline, organizations can ensure consistency, repeatability, and auditability. This aligns with best practices for secure network infrastructure management, emphasizing the principle of least privilege and proactive security posture. The use of declarative configurations reduces the likelihood of human error and allows for rapid rollback if issues arise. This approach supports regulatory requirements for change management, security controls, and incident response by providing a clear audit trail and a mechanism for rapid remediation. Incorrect approaches analysis. An approach that relies solely on manual configuration of firewall rules on individual hosts or edge nodes is highly susceptible to human error, leading to inconsistencies and security gaps. This violates principles of secure change management and increases the risk of unauthorized access, which could have regulatory implications related to data protection and breach notification. An approach that bypasses the distributed firewall in favor of host-based firewalls for segmentation, without a centralized management and policy enforcement mechanism, creates a fragmented security posture. This makes it difficult to enforce consistent security policies across the entire environment, potentially leading to compliance violations if sensitive data is not adequately protected according to regulatory mandates. An approach that focuses on implementing network segmentation without a clear and documented policy framework, or without a mechanism for regular review and auditing of those policies, fails to meet the requirements for effective security governance. This lack of oversight can lead to outdated or ineffective security controls, increasing the risk of non-compliance with data privacy and security regulations. Professional reasoning. Professionals must adopt a proactive and automated approach to network security implementation. This involves understanding the specific security and compliance requirements of the organization and leveraging the capabilities of NSX to enforce those requirements consistently. A robust change management process, including thorough testing and validation of automated deployments, is essential. Regular auditing of security configurations and access logs is also critical to identify and address any deviations from policy. Question 4. Performance analysis shows a noticeable increase in latency and packet loss for critical application traffic traversing the NSX data center fabric. The issue appears intermittent and affects multiple segments. What is the most professional and compliant approach to begin diagnosing this problem? Option A. Temporarily disable distributed firewall (DFW) rules for affected segments to determine if security policies are contributing to the latency. Option B. Immediately implement a broad set of firewall rule changes to isolate potential problem areas, prioritizing traffic flow for critical applications. Option C. Directly access and modify NSX edge node configurations to adjust resource allocation and network interface settings. Option D. Review NSX manager logs, NSX edge node logs, and vSphere performance metrics for anomalies, and correlate these with observed traffic patterns. Correct answer is D. Review NSX manager logs, NSX edge node logs, and vSphere performance metrics for anomalies, and correlate these with observed traffic patterns. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where performance degradation is observed, but the root cause is not immediately apparent. The professional's task is to identify the most effective and compliant method for troubleshooting. The challenge lies in balancing the need for rapid resolution with the imperative to adhere to established operational procedures and security policies, which are implicitly governed by the principles of responsible IT management and data integrity, expected within a professional VMware NSX data center environment. Missteps can lead to extended downtime, security vulnerabilities, or non-compliance with internal governance. Correct approach analysis. The correct approach involves a systematic, layered investigation that begins with non-intrusive data collection and analysis. This aligns with best practices for network troubleshooting, emphasizing the preservation of system state and the avoidance of introducing further variables. By first examining NSX's built-in monitoring and logging capabilities, and then correlating this with vSphere and host-level metrics, the professional can efficiently pinpoint the source of the performance issue without disrupting ongoing operations. This methodical approach minimizes risk and ensures that any subsequent actions are targeted and informed, reflecting a commitment to operational stability and data integrity. Incorrect approach is analysis. Implementing broad firewall rule changes without a clear understanding of the impact is a significant regulatory and ethical failure. Such actions can inadvertently block legitimate traffic, leading to service disruptions and potential breaches of service-level agreements, SLAs. This demonstrates a lack of due diligence and a disregard for the principle of least privilege, which is fundamental to secure network design and operation. Directly modifying NSX edge node configurations without prior analysis or a rollback plan is also professionally unacceptable. This bypasses established change management processes and introduces a high risk of system instability or complete failure. It violates the ethical obligation to maintain system integrity and can lead to data loss or corruption, which are serious breaches of professional responsibility. Disabling security features like distributed firewall, DFW rules, or gateway firewall, GWFW, rules as a primary troubleshooting step is a critical security and compliance failure. This exposes the network to potential threats and violates the fundamental security posture that NSXT is designed to enforce. It demonstrates a lack of understanding of the security implications and a failure to uphold the duty of care to protect the network and its data. Professional reasoning. Professionals should approach performance issues with a structured methodology. This involves 1. Understanding the reported symptoms and their scope. 2. Consulting existing documentation and baseline performance metrics. 3. Utilizing native monitoring and logging tools first. 4. Correlating data across different layers of the infrastructure, NSXT vSphere hosts. 5. Formulating hypotheses based on collected data. 6. Implementing targeted changes with clear rollback plans following change management procedures. 7. Documenting all steps taken and their outcomes. This systematic process ensures that troubleshooting is efficient, effective, and compliant with operational and security best practices. Question 5. Risk assessment procedures indicate that the rapid deployment of new NSXT logical segments is critical for supporting agile application development. But there is a concern that security and compliance configurations may be overlooked in the rush to provision. Which of the following approaches best balances the need for agility with robust security and compliance posture? Option A. Create NSXT logical segments without immediate security policy association, relying on subsequent, ad hoc security scans and manual remediation efforts to identify and address any security gaps. Option B. Implement a single, broad security policy that applies to all newly created NSXT logical segments to simplify management and ensure basic network connectivity. Option C. Integrate security group assignments, an initial firewall rule, sets directly into the NSXT logical segment creation workflow, ensuring that segments are provisioned with baseline security controls aligned with organizational policies from the outset. Option D. Delegate the responsibility for defining and applying security policies to individual application teams after the NSXT logical segments have been provisioned and are operational. The correct answer is C. Integrate security group assignments, an initial firewall rule, sets directly into the NSXT logical segment creation workflow, ensuring that segments are provisioned with baseline security controls aligned with organizational policies from the outset. Explanation. This scenario presents a professional challenge in balancing the immediate need for network agility with the long-term implications of security posture and compliance. The core difficulty lies in ensuring that rapid deployment of new NSX segments, driven by business requirements, does not inadvertently create security gaps or violate established organizational policies and regulatory mandates. The professional must exercise judgment to integrate security and compliance considerations into the very fabric of the deployment process, rather than treating them as afterthoughts. The correct approach represents best professional practice because it embeds security and compliance checks directly into the NSX segment creation workflow. This proactive stance aligns with the principle of security by design and compliance by design, which are fundamental to modern IT governance. By leveraging NSX's capabilities for microsegmentation and policy enforcement at the time of segment creation, the organization ensures that security controls are applied consistently and automatically, reducing the risk of human error and policy drift. This approach also facilitates easier auditing and reporting, as security and compliance configurations are directly tied to the network infrastructure. From a regulatory perspective, this demonstrates due diligence in implementing controls to protect sensitive data and maintain operational integrity, which is often a requirement for frameworks like GDPR, HIPAA, or PCI DSS, depending on the specific industry and data handled. An incorrect approach that prioritizes speed over thoroughness by creating segments without immediate security policy association is professionally unacceptable. This failure constitutes a significant regulatory and ethical lapse. It directly contravenes the principle of least privilege and the requirement for robust access controls, potentially exposing sensitive data to unauthorized access. Such an oversight could lead to non-compliance with data protection regulations, resulting in severe financial penalties and reputational damage. Furthermore, it demonstrates a lack of professional responsibility in safeguarding the organization's assets and data. Another incorrect approach, which involves relying solely on post-deployment security scans to identify vulnerabilities, is also professionally deficient. While post-deployment checks have their place, they are reactive rather than proactive. This method fails to prevent the initial creation of insecure configurations, leaving the network vulnerable during the interim period. It also increases the burden on security teams to constantly remediate issues that could have been prevented at the source. Ethically, this represents a failure to implement best practices for risk mitigation and a potential disregard for the organization's security posture. A third incorrect approach, which involves creating generic, overly permissive security policies for all new segments, is equally problematic. While seemingly efficient, it undermines the principle of microsegmentation and granular security. Overly permissive policies increase the attack surface and make it difficult to isolate compromised systems. This approach fails to meet the specific security needs of different workloads and data classifications, thereby increasing the risk of lateral movement by attackers. It also hinders effective incident response and forensic analysis. Professionally, this demonstrates a lack of understanding of the nuanced security requirements of a modern, dynamic network environment, and a failure to adhere to the principle of least privilege. The professional decision-making process for similar situations should involve a structured approach. First, thoroughly understand the business requirement driving the need for new network segments. Second, consult relevant security and compliance policies to identify mandatory controls and configurations. Third, leverage NSX's native capabilities to implement these controls as part of the segment creation process, utilizing features like security groups, firewall rules, and distributed firewall policies. Fourth, document the security and compliance rationale for each segment's configuration. Finally, establish a continuous monitoring and auditing process to ensure ongoing adherence to policies and to adapt to evolving threats and regulatory landscapes. Question 6. Analysis of a situation where a critical network performance issue is impacting multiple customers, and a third-party vendor is contracted to assist with troubleshooting. The investigation requires access to network traffic captures and system logs within the VMware NSX environment, which are known to contain sensitive customer data. What is the most ethically and professionally responsible approach to proceed with the investigation? Option A. Postpone the investigation indefinitely until a perfect, risk-free method for data access can be identified to avoid any potential data privacy concerns. Option B. Share all raw network traffic captures and system logs directly with the third-party vendor without any prior data sanitization or explicit data handling agreements. Option C. Anonymize or pseudonymize sensitive data within traffic captures and logs before the investigation, and ensure access to these sanitized resources is strictly controlled and limited to authorized personnel. Option D. Grant the third-party vendor and internal teams immediate, unrestricted access to all raw network traffic captures and system logs to expedite the troubleshooting process. The correct answer is C. Anonymize or pseudonymize sensitive data within traffic captures and logs before the investigation, and ensure access to these sanitized resources is strictly controlled and limited to authorized personnel. Explanation. Scenario analysis. This scenario presents a professional challenge related to data privacy and security within a virtualized network environment managed by VMware NSX. The core dilemma lies in balancing the immediate need for network troubleshooting and performance analysis with the ethical and regulatory obligations to protect sensitive customer data. The potential for accidental exposure or misuse of this data during an investigation, especially when dealing with a third-party vendor, elevates the complexity and requires careful judgment. The professional must navigate the technical requirements of the task against the imperative of data confidentiality and compliance. Correct approach analysis. The correct approach prioritizes data anonymization and access control before any investigation commences. This aligns with best practices for data protection and regulatory compliance, such as those that might be stipulated by data privacy laws. Though specific laws are not mentioned for this exam, the principle of data protection is universal in professional IT. By anonymizing or pseudonymizing sensitive data elements within logs and traffic captures, the risk of unauthorized disclosure is significantly mitigated. Furthermore, restricting access to the investigation tools and the anonymized data to only essential personnel ensures that the principle of least privilege is upheld, further safeguarding sensitive information. This proactive approach demonstrates a commitment to ethical conduct and adherence to data handling policies, preventing potential breaches and regulatory violations. Incorrect approaches analysis. An approach that involves immediate, unfettered access to raw network traffic and logs without any prior data sanitization poses a significant ethical and regulatory risk. This could lead to the accidental exposure of personally identifiable information, PI, or other sensitive customer data to individuals who do not have a legitimate need to access it. Such an action could violate data privacy principles and potentially contravene regulations governing data handling and breach notification, even if unintentional. Another incorrect approach would be to delay the investigation indefinitely due to concerns about data privacy, without exploring any mitigation strategies. While caution is warranted, an indefinite delay can negatively impact service availability and customer satisfaction. It may not be a sustainable or professional solution. It fails to balance the competing demands of security and operational necessity. Finally, an approach that involves sharing raw, unanonymized data with the third-party vendor without explicit consent or a clear contractual agreement outlining data handling responsibilities is a severe ethical and regulatory failure. This bypasses established data protection protocols and could result in a data breach, leading to reputational damage and legal repercussions. Professional reasoning. Professionals in this field must adopt a risk-based decision-making framework. This involves identifying potential risks, e.g., data exposure, assessing their likelihood and impact, and then implementing controls to mitigate them. In situations involving sensitive data, the default stance should be one of protection. Before any action that might expose data, consider what data is involved, who needs to see it, what are the risks of them seeing it, what steps can be taken to reduce those risks, e.g., anonymization, access controls. Is there a legal or contractual basis for accessing and processing this data? Consulting with legal or compliance teams, if available, is also a crucial step when in doubt. Question 7. Compliance review shows that the NSX data center environment has been configured with security policies that were largely derived from generic vendor recommendations, without a formal, documented risk assessment process specific to the organization's unique operational context and threat profile. What is the most appropriate next step to ensure robust security and compliance? Option A. Rely on the existing vendor-provided security best practices as a baseline and assume that the current configuration adequately addresses organizational risks. Option B. Focus on automating the deployment of security policies to increase efficiency, assuming that automated configurations are inherently secure. Option C. Conduct a comprehensive risk assessment to identify critical assets, vulnerabilities, and threat vectors, and then tailor NSX security policies based on the findings. Option D. Immediately implement additional security controls across all NSX segments to compensate for the perceived lack of rigor in the initial policy configuration. The correct answer is C. Conduct a comprehensive risk assessment to identify critical assets, vulnerabilities, and threat vectors, and then tailor NSX security policies based on the findings. Explanation. Scenario analysis. This scenario presents a common challenge in network security compliance, balancing the need for robust security controls with the operational realities of a dynamic, multi-tenant cloud environment. The professional VMware NSX data center administrator must interpret and apply security policies across diverse workloads, each with potentially different risk profiles and compliance mandates. The challenge lies in ensuring that the risk assessment process is not merely a perfunctory exercise, but a dynamic and effective mechanism for identifying, prioritizing, and mitigating security risks in accordance with the organization's security posture and any applicable regulatory frameworks. The inherent complexity of NSX, with its distributed architecture and software-defined networking capabilities, adds another layer of difficulty, requiring a nuanced understanding of how security policies translate into actual network configurations and how those configurations impact the overall risk landscape. Correct approach analysis. The correct approach involves a systematic and documented risk assessment that considers the specific threat landscape, vulnerabilities within the NSX environment, and the potential impact of a security incident on business operations and compliance. This assessment should leverage NSX's microsegmentation capabilities to define security zones based on workload criticality and data sensitivity. It necessitates a continuous monitoring and reevaluation process, as the threat landscape and the network environment are constantly evolving. This approach aligns with best practices for risk management, emphasizing proactive identification and mitigation. From a regulatory perspective, a well-documented and consistently applied risk assessment process is often a fundamental requirement for demonstrating due diligence and compliance with various security standards and regulations. Even if not explicitly detailed in the exam-specific jurisdiction, the underlying principles of risk management are universally applicable to secure IT operations. Incorrect approaches analysis. Implementing security controls solely based on vendor best practices without a specific risk assessment tailored to the organization's environment is a significant regulatory and ethical failure. This approach ignores the unique threat vectors and vulnerabilities present in the specific deployment, potentially leaving critical assets unprotected or imposing unnecessary restrictions on less sensitive workloads. It demonstrates a lack of due diligence and a failure to adequately understand and manage organizational risk. Applying a one-size-fits-all security policy across all NSX segments without considering the varying risk profiles of different workloads is another failure. This approach is inefficient and ineffective. It can lead to overprotection of low-risk assets, hindering performance and agility, while underprotecting high-risk assets, creating significant security gaps. This demonstrates a failure to prioritize resources and a lack of understanding of risk-based security principles, which are foundational to effective compliance. Relying solely on automated security policy generation without human oversight and validation is also problematic. While automation is crucial for efficiency, it can miss subtle but critical risks that require human judgment and contextual understanding. This approach risks introducing misconfigurations or overlooking specific compliance requirements that are not easily quantifiable by automated tools, leading to potential security and compliance breaches. Professional reasoning. Professionals should adopt a risk-based approach to security policy design and implementation within NSX. This involves 1. Identifying critical assets and data. 2. Understanding the threat landscape relevant to the organization and its industry. 3. Assessing vulnerabilities within the NSX infrastructure and the workloads it protects. 4. Evaluating the potential impact of security incidents. 5. Prioritizing risks based on likelihood and impact. 6. Designing and implementing security controls, e.g., microsegmentation, firewall rules, to mitigate identified risks. 7. Regularly reviewing and updating the risk assessment and security controls to adapt to changes in the environment and threat landscape. This systematic process ensures that security investments are targeted effectively and that compliance objectives are met in a practical and sustainable manner. Question 8. The audit findings indicate that a critical network service experienced an unexpected outage due to a misconfiguration in a VMware NSX data center segment. The network engineer responsible for the segment believes they know the exact fix, but is concerned about the time it will take to go through the formal change management process, which involves security team review and approval before implementation. The engineer is considering implementing the fix immediately to restore service quickly, documenting it later. What is the most appropriate course of action for the network engineer? Option A. Immediately implement the fix to restore service and then document the change and submit it for retrospective approval. Option B. Immediately implement the fix to restore service and then document the change and submit it for retrospective approval. Option C. Immediately implement the fix to restore service and then document the change and submit it for retrospective approval. Option D. Immediately implement the fix to restore service and then document the change and submit it for retrospective approval. The correct answer is D. Immediately implement the fix to restore service and then document the change and submit it for retrospective approval. Explanation. This scenario presents a professional challenge due to the potential conflict between immediate operational needs and long-term security best practices, as highlighted by the audit. The core of the dilemma lies in balancing the urgency of restoring service with the imperative to adhere to established security protocols and regulatory compliance, particularly concerning the handling of sensitive network configurations. The correct approach represents best professional practice because it prioritizes a systematic and documented remediation process. By engaging the security team and following established change management procedures, the network engineer ensures that any modifications are reviewed, approved, and implemented in a controlled manner. This aligns with the principles of responsible IT governance and the need to maintain the integrity and security of the network infrastructure, which is paramount in a regulated environment. Adherence to these processes minimizes the risk of introducing new vulnerabilities or violating compliance mandates. An incorrect approach that bypasses established security review processes and directly implements changes based on a perceived urgency is professionally unacceptable. This action constitutes a significant regulatory and ethical failure. It demonstrates a disregard for the established security framework, potentially leading to unauthorized access, data breaches, or noncompliance with data protection regulations. Such a shortcut undermines the audit's findings and creates a precedent for future security lapses. Another incorrect approach, which involves documenting the change retrospectively without prior approval, also fails to meet professional standards. While it attempts to create a record, it still circumvents the crucial pre-implementation review and approval stages. This can lead to the introduction of insecure configurations that are only identified after the fact, increasing the risk of security incidents and making remediation more complex and costly. It also fails to demonstrate proactive security management. A further incorrect approach, which involves making the change without any documentation, is the most egregious. This represents a complete abdication of professional responsibility and a direct violation of audit and compliance requirements. It leaves the network in an unmanaged and unmonitored state, making it impossible to track changes, troubleshoot issues, or demonstrate compliance during future audits. This lack of transparency and accountability is a critical ethical and regulatory failure. The professional reasoning process for navigating such situations involves a clear understanding of the organization's security policies, regulatory obligations, and change management procedures. When faced with an urgent operational issue that may conflict with these, the professional should first assess the immediate risk and potential impact. Then, they should consult with relevant stakeholders, including security and compliance teams, to determine the safest and most compliant course of action. Prioritizing documented, approved, and controlled changes, even under pressure, is essential for maintaining professional integrity and ensuring the security and compliance of the network infrastructure. Question 9. Research into the implementation of microsegmentation within a VMware NSX data center environment for a financial services organization operating under strict data privacy and security regulations, has identified a need to enforce granular security policies that prevent unauthorized lateral movement of threats. The organization is considering different architectural approaches to achieve this. Which of the following approaches best aligns with the principles of least privilege and provides the most robust, auditable, and compliant security posture for sensitive workloads? Option A. Implementing a distributed firewall with security groups dynamically populated based on workload identity and application tags, enforcing policies that permit only necessary communication flows between logical tiers and services. Option B. Deploying a perimeter firewall with extensive access control lists, ACL, to filter traffic, while allowing internal network segments to remain largely unconstrained. Option C. Relying on traditional VLAN-based network segmentation and static firewall rules configured at the network edge to control traffic between different application environments. Option D. Designing a flat network architecture with minimal internal segmentation and primarily utilizing endpoint security solutions for threat detection and prevention. Correct answer is A. Implementing a distributed firewall with security groups dynamically populated based on workload identity and application tags, enforcing policies that permit only necessary communication flows between logical tiers and services. Explanation. This scenario presents a professional challenge in network security architecture design within a regulated environment, specifically concerning the implementation of microsegmentation using VMware NSX data center. The core difficulty lies in balancing the stringent security requirements mandated by regulatory frameworks with the operational efficiency and scalability needs of the organization. Professionals must demonstrate a deep understanding of NSX's capabilities, the specific compliance obligations, and the potential implications of architectural choices on both security posture and business continuity. Careful judgment is required to select an approach that is not only technically sound, but also demonstrably compliant and auditable. The correct approach represents best professional practice because it prioritizes a granular, identity-based security policy that aligns directly with the principle of least privilege, a fundamental tenet of most cybersecurity regulations and best practices. By leveraging NSX's distributed firewall and security groups, an administrator can enforce policies based on logical groupings of workloads, e.g., by application tier, compliance domain, or user role, rather than static IP addresses. This dynamic and context-aware security model is highly effective in preventing lateral movement of threats and ensuring that only authorized communication flows are permitted. This approach is auditable, as the security policies are centrally managed and can be easily reported on to demonstrate compliance with specific regulatory controls. It also allows for more agile security management as the infrastructure evolves. An incorrect approach that relies solely on network segmentation using traditional VLAN and firewall rules based on IP addresses is professionally unacceptable. This method fails to meet the dynamic nature of modern cloud-native applications and microservices, making it difficult to maintain granular control and enforce the principle of least privilege effectively. From a regulatory perspective, it can lead to a failure to demonstrate adequate controls against unauthorized access and data exfiltration, potentially violating compliance mandates that require robust segmentation and access control mechanisms. Furthermore, it is less auditable and more prone to misconfiguration errors as the network grows. Another incorrect approach that involves implementing a flat network with minimal segmentation and relying solely on endpoint security solutions is also professionally unacceptable. This strategy fundamentally undermines the concept of defense in depth and fails to address the critical requirement for network-level controls mandated by many regulations. In the event of a compromise on one endpoint, the attacker would have unfettered access to the entire network, leading to a significant breach of confidentiality, integrity, and availability. This approach would likely be flagged during any security audit as a severe deficiency in network security architecture, violating regulations that emphasize network segmentation and containment. The professional decision-making process for similar situations should involve a thorough understanding of the organization's specific regulatory obligations, a comprehensive assessment of the threat landscape, and a detailed evaluation of the technical capabilities of the chosen security platform. In this case, VMware NSX. Professionals should engage in a risk-based approach, prioritizing controls that address the most critical risks and compliance requirements. Documentation of the design decisions, including the rationale for selecting specific NSX features and policy configurations, is crucial for auditability and ongoing management. Continuous monitoring and regular review of security policies are also essential to adapt to evolving threats and business needs. Question 10. Quality control measures reveal that a specific application's traffic is intermittently failing to reach its intended destination within the NSX data center environment, despite the application servers reporting no internal issues. Network administrators are alerted to a potential misconfiguration or security policy violation. Option A. Review the NSX firewall rules and security group memberships applied to the affected application segments and workloads to ensure they permit the necessary traffic. Option B. Initiate a full network packet capture across all NSX components involved in the traffic path and analyze the data for anomalies. Option C. Immediately disable the NSX firewall for all affected network segments to see if traffic flow resumes. Option D. Implement broad, reactive network segmentation changes to isolate potential problematic areas without a precise understanding of the anomaly's cause. The correct answer is A. Review the NSX firewall rules and security group memberships applied to the affected application segments and workloads to ensure they permit the necessary traffic. Explanation. Scenario analysis. This scenario presents a common challenge in network security operations, a detected anomaly that could indicate a misconfiguration or a genuine security threat. The professional challenge lies in accurately diagnosing the root cause without disrupting legitimate network traffic or compromising security posture. The urgency of a potential security breach necessitates a swift yet methodical response, balancing operational continuity with risk mitigation. The specific context of NSX, with its distributed architecture and policy-driven security, adds complexity, as a misconfiguration can have widespread implications. Correct approach analysis. The correct approach involves a systematic investigation, starting with the most probable and least disruptive causes. This aligns with best practices in IT incident response and network security, emphasizing a phased approach to troubleshooting. The initial step of reviewing NSX firewall rules and security group memberships is crucial because these are the primary mechanisms for controlling traffic flow and enforcing security policies within the NSX environment. Verifying that the rules are correctly configured and applied to the intended logical entities, like segments or workloads, directly addresses the observed traffic anomaly. This methodical approach minimizes the risk of unintended consequences, such as blocking legitimate traffic or introducing new vulnerabilities, while efficiently pinpointing the source of the problem. This adheres to the principle of least privilege and the importance of maintaining a secure and functional network infrastructure, which are foundational to operational integrity and compliance. Incorrect approach is analysis. Disabling the NSX firewall entirely without a clear understanding of the anomaly's nature or impact is a significant regulatory and ethical failure. This action bypasses the security controls designed to protect the network, exposing it to potential threats and violating the principle of maintaining a secure environment. It is a reactive and irresponsible measure that prioritizes immediate and potentially false problem resolution over fundamental security responsibilities. Immediately escalating to a full network packet capture across all affected components without first performing basic configuration checks is inefficient and can overwhelm troubleshooting resources. While packet capture is a valuable tool, it should be employed after initial hypotheses have been formed and tested. This approach lacks a structured problem-solving methodology and can lead to a deluge of data that obscures the actual issue, delaying resolution and potentially consuming excessive resources, which could be seen as a failure in resource management and operational efficiency. Implementing broad, reactive network segmentation changes without a clear understanding of the anomaly's scope or impact is also problematic. Such changes, if not precisely targeted, can inadvertently isolate critical services, disrupt business operations, and create new security gaps. This approach demonstrates a lack of analytical rigor and a failure to adhere to change management best practices, which require understanding the cause and effect of any network modification. Professional reasoning, professionals should adopt a structured incident response framework. This typically involves 1. Identification and scoping. Understand the reported issue and its potential impact. 2. Containment. Prevent further spread or damage if a security incident. 3. Diagnosis. Systematically investigate the root cause, starting with the most likely and least disruptive possibilities. 4. Eradication. Remove the cause of the problem. 5. Recovery. Restore normal operations. 6. Lessons learned. Document the incident and identify improvements. In this scenario, the professional decision-making process prioritizes verifying the integrity and correctness of the security controls, firewall rules, security groups, as the most logical first step in diagnosing a traffic anomaly with an NSX. This methodical approach ensures that the investigation is efficient, effective, and minimizes operational risk. Question 11. Stakeholder feedback indicates a potential zero-day exploit targeting a critical application hosted within the NSX virtualized environment. The security operations team has limited time to respond before the exploit could cause significant data exfiltration. They need to implement immediate containment measures while minimizing disruption to legitimate business operations and adhering to established change management protocols as much as possible. Which of the following approaches best balances these competing demands? Option A. Immediately apply NSX distributed firewall rules to isolate the affected application tier and its dependencies, blocking known malicious traffic signatures associated with the exploit, and initiate a rapid, documented rollback plan for any recent changes to that specific application's security profile. Option B. Implement a broad, network-wide firewall rule change to block all inbound traffic to the affected application subnet, bypassing standard change control procedures due to the urgency. Option C. Disable all security features and policies within NSX for the affected application segment to simplify troubleshooting and gain immediate visibility into traffic flows. Option D. Perform an immediate, uncoordinated rollback of all recent network configuration changes across the entire data center to revert to a known stable state, without specific analysis of the exploit's impact. The correct answer is A. Immediately apply NSX distributed firewall rules to isolate the affected application tier and its dependencies, blocking known malicious traffic signatures associated with the exploit, and initiate a rapid, documented rollback plan for any recent changes to that specific application's security profile. Explanation. Scenario analysis. This scenario presents a common challenge in network security and compliance, balancing the need for rapid threat mitigation with the imperative to adhere to established change management and security policy frameworks. The urgency of a potential zero-day exploit creates pressure to bypass standard procedures, which could lead to unintended consequences, security vulnerabilities, or regulatory noncompliance if not handled judiciously. The challenge lies in making a swift, informed decision that prioritizes security without compromising the integrity of the operational environment or violating established governance. Correct approach analysis. The correct approach involves a structured, risk-based decision-making process that leverages existing security tools and documented procedures, even under pressure. This aligns with best practices for incident response and security operations, which emphasize containment, eradication, and recovery within a controlled framework. By utilizing NSX's micro-segmentation capabilities to isolate affected workloads and applying dynamic security policies, the security team can effectively mitigate the immediate threat without a full, disruptive rollback or the introduction of unvetted changes. This approach demonstrates adherence to the principle of least privilege and defense in depth, core tenets of modern network security. It also reflects a commitment to maintaining operational stability and auditability, crucial for regulatory compliance and business continuity. The use of NSX's native capabilities for policy enforcement and threat containment is a direct application of the technology's intended purpose in a security-critical situation. Incorrect approaches analysis. Implementing a broad, network-wide firewall rule change without thorough testing or a clear rollback plan is a significant regulatory and ethical failure. Such an action bypasses established change management processes, increasing the risk of misconfiguration, service disruption, and the introduction of new security holes. This approach fails to adhere to the principle of controlled change, which is often a requirement in compliance frameworks that mandate documented and approved modifications to security infrastructure. Disabling security features or policies across the entire environment to gain visibility or simplify troubleshooting is another critical failure. This directly contradicts the fundamental purpose of security controls and exposes the network to a wider range of threats, especially in the context of a known zero-day exploit. It represents a dereliction of duty in protecting the organization's assets and data, and would likely violate numerous security standards and regulations that mandate the continuous enforcement of security policies. Performing an immediate and coordinated rollback of all recent network changes without proper analysis is also problematic. While rollback can be a valid incident response step, doing so without understanding the root cause or the impact of the rollback itself can lead to further instability and may not effectively address the specific threat. This approach lacks the analytical rigor required for effective incident response and can lead to a reactive rather than proactive security posture, potentially missing the actual vulnerability or introducing new issues. Professional reasoning. Professionals facing such a scenario should first activate their organization's documented incident response plan. This plan should outline steps for threat assessment, containment, and remediation. The decision-making process should prioritize understanding the specific threat and its potential impact. Leveraging the capabilities of the deployed security platform, in this case NSX, to implement granular, targeted controls is paramount. This includes utilizing microsegmentation to isolate potentially compromised systems and applying dynamic security policies to block malicious traffic patterns. Any changes made must be logged, and a clear rollback strategy should be defined and tested, even if the immediate action is to contain rather than fully remediate. The goal is to achieve security objectives while maintaining operational integrity and auditability, thereby upholding professional responsibility and regulatory compliance. Question 12. Which approach would be most effective in ensuring a VMware NSX data center environment used by a U.S.-based financial services firm meets the rigorous compliance mandates of the U.S. Securities and Exchange Commission, SEC, regarding data protection and network security? Option A. Implementing NSX security policies that directly map to SEC compliance requirements, automating their enforcement, and establishing comprehensive logging and auditing for continuous monitoring and reporting. Option B. Prioritizing the deployment of advanced NSX security features without a formal process for documenting how each feature contributes to specific SEC compliance objectives. Option C. Conducting extensive penetration testing of the NSX environment and assuming compliance based on successful test outcomes. Option D. Relying on periodic manual audits of NSX configurations to identify and rectify any deviations from SEC compliance standards. The correct answer is A. Implementing NSX security policies that directly map to SEC compliance requirements, automating their enforcement, and establishing comprehensive logging and auditing for continuous monitoring and reporting. Explanation. This scenario presents a professional challenge in ensuring that network security configurations within a VMware NSX data center environment adhere to stringent regulatory compliance requirements, specifically those mandated by the U.S. Securities and Exchange Commission, SEC, for financial institutions. The core difficulty lies in balancing the dynamic nature of cloud-native network deployments with the static, auditable requirements of regulatory frameworks. Organizations must demonstrate not just technical implementation, but also the processes and controls that guarantee ongoing compliance. The correct approach represents best professional practice because it proactively integrates regulatory compliance into the network design and operational lifecycle. By establishing clear policies, leveraging NSX's native security features for enforcement, and implementing robust logging and auditing mechanisms, the organization can provide verifiable evidence of adherence to SEC regulations. This demonstrates a commitment to security and compliance, minimizing the risk of regulatory penalties and reputational damage. The use of automated policy enforcement and continuous monitoring aligns with the SEC's expectations for robust cybersecurity programs. An incorrect approach that relies solely on manual configuration reviews fails to address the dynamic nature of network changes and the potential for human error. This creates significant regulatory and ethical failures by introducing a high risk of non-compliance that may go undetected until an audit. It demonstrates a reactive rather than proactive stance, which is unacceptable under SEC guidelines that emphasize preventative controls. Another incorrect approach that prioritizes feature implementation over documented compliance processes is also professionally unacceptable. This leads to a situation where the network may technically function, but the organization cannot prove its compliance. This lack of auditable evidence is a direct violation of regulatory requirements and exposes the organization to severe penalties. It signifies a failure to understand the fundamental purpose of regulatory frameworks, which is to ensure accountability and transparency. The professional reasoning process for similar situations should involve a thorough understanding of applicable regulations, a comprehensive assessment of the technology's capabilities in meeting those regulations, and the establishment of clear, documented processes for design, implementation, operation, and auditing. Professionals must prioritize solutions that offer verifiable compliance and integrate security and regulatory considerations from the outset, rather than treating them as an afterthought. This involves a risk-based approach, identifying critical compliance areas, and ensuring that technical controls and operational procedures adequately mitigate those risks. Question 13. The review process indicates that the security operations team is preparing to implement a new set of distributed firewall rules within the NSX data center environment to enhance protection for critical application servers. Given the potential impact on service availability and the need to ensure compliance with data protection guidelines, what is the most professionally responsible approach for deploying these rules? Option A. Implement the new distributed firewall rules in monitor-only mode, first to observe traffic patterns and validate their effectiveness before enabling blocking. Option B. Deploy the new distributed firewall rules directly in block mode to immediately enforce the desired security posture. Option C. Configure the new distributed firewall rules solely based on technical specifications, without consulting with application owners or business stakeholders. Option D. Apply the new distributed firewall rules based on generic vendor best practices, without specific validation, against the current traffic flows. The correct answer is B. Deploy the new distributed firewall rules directly in block mode to immediately enforce the desired security posture. Explanation. Scenario analysis. This scenario presents a professional challenge related to the implementation of NSX data center security policies, specifically focusing on distributed firewall rules. The challenge lies in balancing the need for robust security with operational efficiency and compliance requirements. A misconfiguration or oversight in applying these rules can lead to security vulnerabilities or unintended service disruptions, impacting business operations and potentially violating regulatory mandates for data protection and network availability. The stakeholder perspective in this case, the security operations team, requires a solution that is both effective and manageable. Correct approach analysis. The correct approach involves a phased deployment and validation strategy for distributed firewall rules. This aligns with best practices for network security and compliance. Specifically, applying rules in a monitor-only mode first allows the security operations team to observe the traffic patterns and identify any potential false positives or unintended blocks before enforcing the rules. This proactive validation minimizes the risk of service disruption and ensures that the rules accurately reflect the organization's security posture and operational needs. This approach supports regulatory compliance by demonstrating due diligence in security policy implementation and minimizing the risk of data breaches or unauthorized access, which are often covered by data protection regulations. Incorrect approaches analysis. Implementing distributed firewall rules directly in block mode without prior validation is a significant regulatory and ethical failure. This approach bypasses essential testing and validation steps, increasing the risk of inadvertently blocking legitimate traffic, which can lead to service outages and non-compliance with service-level agreements or availability mandates. It demonstrates a lack of professional due diligence in assessing the impact of security changes. Applying distributed firewall rules based solely on a vendor's default security recommendations, without considering the specific operational context and traffic flows of the organization, is another failure. While vendor defaults can be a starting point, they are rarely a complete solution for a specific environment. This approach can lead to either overblocking, impacting legitimate business functions, or underblocking, leaving critical assets exposed. It fails to meet the professional obligation to tailor security solutions to the unique risks and requirements of the organization, potentially violating compliance frameworks that mandate risk-based security controls. Focusing exclusively on the technical implementation of distributed firewall rules without engaging relevant stakeholders, such as application owners or business unit representatives, is also professionally unsound. This oversight can lead to rules that are technically correct but operationally disruptive. It fails to uphold the ethical responsibility to consider the broader impact of security decisions on the organization and can lead to non-compliance with operational requirements and stakeholder expectations. Professional reasoning. Professionals must adopt a risk-based and iterative approach to network security implementation. This involves understanding the specific environment, engaging with stakeholders, and employing phased deployment and validation strategies. The decision-making process should prioritize minimizing operational impact while maximizing security effectiveness. This includes leveraging available tools and features, such as monitor-only modes, to validate configurations before full enforcement. Adherence to established security frameworks and regulatory requirements should guide every step, ensuring that security measures are both robust and compliant. Question 14. The analysis reveals that a multinational organization is deploying VMware NSX data center across its on-premises data centers and multiple public cloud environments to achieve consistent network security and segmentation. The organization handles sensitive customer data subject to varying data residency and privacy regulations across different jurisdictions. A key implementation challenge is to ensure that network policies dynamically adapt to workload changes while strictly enforcing data access controls and preventing unauthorized data exfiltration, all while maintaining a clear audit trail for compliance reporting. Which of the following implementation strategies best addresses these requirements? Option A. Create broad, permissive firewall rules within NSX to simplify policy management and reduce the administrative burden, with exceptions for critical applications only. Option B. Rely primarily on traditional perimeter firewalls at the edge of each cloud environment and manually configure IP-based access control lists within NSX for specific workload segments. Option C. Implement distributed firewall rules based on security groups and tags, dynamically assigned to workloads, and integrate these policies with cloud-native IAM for unified access control. Option D. Deploy NSX solely for network virtualization and leverage separate, third-party security solutions for all firewalling and segmentation tasks, without deep integration into NSX policies. The correct answer is C. Implement distributed firewall rules based on security groups and tags, dynamically assigned to workloads, and integrate these policies with cloud-native IAM for unified access control. Explanation. The analysis reveals a common implementation challenge in large-scale NSX deployments, ensuring consistent and secure network segmentation across a hybrid cloud environment. The professional challenge lies in balancing the need for rapid deployment and agility with the imperative to maintain strict security controls and compliance with evolving regulatory requirements, particularly concerning data residency and access control. The scenario demands a deep understanding of NSX's distributed firewall capabilities, its integration with cloud-native security policies, and the operational overhead associated with managing these policies at scale. The correct approach represents best professional practice because it leverages NSX's inherent capabilities for granular policy enforcement at the workload level, aligning with the principle of least privilege. By defining security policies based on logical constructs like security groups and tags, and applying them directly to virtual machines or containers, the organization can ensure that segmentation is dynamic and automatically updated as workloads change. This approach is crucial for meeting regulatory mandates that often require strict controls over data flow and access, especially in multi-jurisdictional environments where data residency laws are paramount. The use of centralized management and automation through NSX Manager and potentially vRealize automation or similar orchestration tools further enhances compliance by providing auditable logs and consistent policy application, reducing the risk of human error and shadow IT. An incorrect approach that relies solely on traditional perimeter-based firewalls or manual IP-based access control lists within the NSXT environment fails to address the dynamic nature of modern cloud workloads. This leads to security gaps and compliance risks. Specifically, it violates the principle of defense in depth by not enforcing security at the workload level. Furthermore, manual configuration is prone to errors, increasing the likelihood of misconfigurations that could lead to unauthorized access or data breaches, thereby failing to meet due diligence requirements and potentially violating data protection regulations. Another incorrect approach that involves creating overly broad firewall rules, while seemingly simplifying management, introduces significant security vulnerabilities. This directly contravenes the principle of least privilege and increases the attack surface. Such an approach makes it difficult to audit and prove compliance with specific regulatory requirements that mandate granular control over data access and flow. It also fails to adapt to changes in workload requirements, leading to a constant state of potential noncompliance. A third incorrect approach that neglects to integrate NSXT security policies with the underlying cloud infrastructure's identity and access management (IAM) systems creates a disconnect between network access and user authorization. This can lead to situations where network access is granted without proper user authentication or authorization, a clear violation of security best practices and many regulatory frameworks that emphasize strong authentication and authorization controls. This lack of integration also hinders effective auditing and incident response. The professional reasoning process for this scenario should involve a thorough risk assessment, identifying critical assets and data flows. This should be followed by a design phase that prioritizes a zero-trust security model, leveraging NSXT's micro-segmentation capabilities. Implementation should focus on automation and policy-as-code principles to ensure consistency and auditability. Continuous monitoring and regular policy reviews are essential to adapt to evolving threats and regulatory landscapes. The decision-making framework should always prioritize security and compliance, even if it introduces some initial operational complexity, as the long-term risks of non-compliance far outweigh the short-term benefits of expediency. Question 15. The evaluation methodology shows that when designing a new VMware NSXT data center deployment for an organization handling sensitive customer data, which approach best ensures adherence to data protection and privacy regulations. Option A. Implement a basic network overlay and underlay configuration, assuming that existing server-level security measures are sufficient for regulatory compliance. Option B. Prioritize the deployment of NSXT's micro-segmentation and distributed firewall capabilities to enforce granular access controls and isolate sensitive data segments, while ensuring comprehensive logging is enabled for audit purposes. Option C. Focus on achieving high network throughput and low latency for all virtual machines, with compliance checks performed only after the initial deployment is fully operational. Option D. Deploy NSXT with minimal configuration to reduce complexity, relying on external security appliances to address any specific compliance needs that may arise later. The correct answer is B. Prioritize the deployment of NSXT's micro-segmentation and distributed firewall capabilities to enforce granular access controls and isolate sensitive data segments, while ensuring comprehensive logging is enabled for audit purposes. Explanation. The evaluation methodology shows that understanding and implementing regulatory compliance within a VMware NSXT data center environment is paramount for maintaining security, data integrity, and operational continuity. This scenario is professionally challenging because it requires a deep understanding of how NSXT features can be leveraged to meet specific regulatory mandates, rather than treating compliance as an afterthought. The pressure to deliver functional network infrastructure quickly can sometimes lead to overlooking critical compliance requirements, making careful judgment and proactive planning essential. The correct approach represents best professional practice because it integrates compliance considerations directly into the design and deployment phases of the NSXT environment. This proactive stance ensures that security controls, data handling policies, and auditability mechanisms are built into the fabric of the network from the outset. This aligns with the principle of security by design and compliance by design, which are fundamental to robust regulatory adherence. By selecting NSXT features that inherently support compliance objectives, such as microsegmentation for data isolation, distributed firewalling for granular access control, and logging capabilities for audit trails. The organization demonstrates a commitment to meeting its obligations. This approach minimizes the risk of costly remediation efforts and potential regulatory penalties. An incorrect approach that focuses solely on deploying NSX for performance or basic connectivity without considering regulatory requirements represents a significant regulatory and ethical failure. It demonstrates a lack of due diligence and a failure to uphold the organization's responsibility to protect sensitive data and maintain a compliant operational posture. Specifically, neglecting to implement appropriate access controls or data segregation mechanisms could lead to unauthorized access or data breaches, violating data protection regulations. Furthermore, failing to configure adequate logging and monitoring can hinder auditability, making it impossible to demonstrate compliance to regulatory bodies, which is an ethical breach of transparency and accountability. Another incorrect approach might involve implementing compliance controls in a piecemeal fashion after deployment, which is often inefficient, prone to errors, and may not fully address the underlying regulatory intent. This reactive approach can lead to security gaps and compliance deficiencies, exposing the organization to risks. Professionals should adopt a decision-making framework that prioritizes understanding the specific regulatory landscape applicable to their organization and industry. This involves identifying relevant compliance frameworks, e.g., GDPR, HIPAA, PCI DSS, if applicable to the exam's implied jurisdiction, and then mapping these requirements to the capabilities of VMware NSX. The process should involve close collaboration with legal, compliance, and security teams to ensure all mandates are addressed. When designing or modifying the NSX environment, professionals should actively seek out and configure features that directly support these compliance objectives, documenting all decisions and configurations for audit purposes. Regular reviews and updates to the NSX configuration should also be conducted to ensure ongoing compliance as regulations and the threat landscape evolve. Question 16. The efficiency study reveals that a specific NSX security feature, while effective in threat mitigation, is contributing to significant latency in critical application traffic. The operations team proposes disabling this feature temporarily to improve application performance, citing user complaints and potential business impact from slow response times. Option A. Implement configuration tuning on the security feature to optimize its performance without disabling it, and monitor the results closely. Option B. Disable the security feature and inform the security team after the change has been made, to allow them to assess the new security posture. Option C. Conduct a thorough risk assessment to understand the security implications of disabling the feature, consult with the security team, develop a detailed rollback plan, and implement the change during a scheduled maintenance window with enhanced monitoring. Option D. Immediately disable the security feature to address the performance complaints, as user experience and application responsiveness are the highest priorities. The correct answer is C. Conduct a thorough risk assessment to understand the security implications of disabling the feature, consult with the security team, develop a detailed rollback plan, and implement the change during a scheduled maintenance window with enhanced monitoring. Explanation. Scenario analysis. This scenario presents a common challenge in network security and operations, balancing performance optimization with the need for robust security controls. The efficiency study highlights a potential performance bottleneck, but the proposed solution directly impacts security posture. The professional challenge lies in making a decision that upholds both operational efficiency and the integrity of the security framework, without compromising compliance with VMware NSX best practices and potential regulatory requirements that mandate specific security controls. The urgency to resolve performance issues can create pressure to bypass or weaken security measures, which is a critical point of professional judgment. Correct approach analysis. The correct approach involves a thorough risk assessment and a phased implementation strategy. This aligns with professional best practices in cybersecurity and network management, which emphasize a proactive and controlled approach to changes. Specifically, it involves 1. Detailed analysis of the impact of disabling the security feature on the overall security posture, considering potential attack vectors and data sensitivity. 2. Consultation with security stakeholders to ensure alignment with organizational security policies and compliance mandates. 3. Developing a rollback plan in case of unforeseen security incidents. 4. Implementing the change during a maintenance window with enhanced monitoring. 5. Re-enabling and retesting the security feature after performance validation, potentially with configuration tuning rather than outright disabling. This methodical approach ensures that security is not sacrificed for performance and that any changes are made in a controlled, auditable, and compliant manner. It reflects a commitment to maintaining a secure and resilient network infrastructure, which is paramount in professional IT operations. Incorrect approach is analysis. Disabling the security feature without a comprehensive risk assessment and stakeholder consultation is a significant regulatory and ethical failure. It demonstrates a disregard for established security protocols and potentially violates organizational policies that mandate specific security controls. This approach prioritizes short-term performance gains over long-term security, creating vulnerabilities that could lead to data breaches, service disruptions, and non-compliance with industry regulations or internal security standards. It also bypasses the necessary change management processes, making it difficult to track, audit, and revert changes, which is a critical failure in professional IT governance. Implementing the change immediately without any testing or rollback plan is another critical failure. This is a reactive and high-risk approach that demonstrates a lack of foresight and professional responsibility. It exposes the network to immediate security threats and operational instability. The absence of a rollback plan means that if the change causes adverse effects, recovery will be significantly more difficult and time-consuming, potentially leading to extended downtime and reputational damage. This directly contradicts the principles of responsible system administration and change management. Focusing solely on performance metrics without considering the security implications is a fundamental flaw in professional decision-making. Security and performance are often intertwined, and optimizing one at the expense of the other can lead to systemic weaknesses. This approach ignores the principle of defense in depth and the potential for cascading failures. It suggests a lack of understanding of the holistic nature of network security and operational management, which is a serious professional deficiency. Professional reasoning. Professionals should adopt a structured decision-making process that prioritizes security and compliance. This involves 1. Understanding the business impact of both performance issues and potential security compromises. 2. Identifying all relevant stakeholders, e.g., security team, operations team, compliance officers. 3. Conducting a thorough risk assessment for any proposed change, evaluating potential threats, vulnerabilities, and impacts. 4. Developing a clear plan that includes implementation steps, testing procedures, monitoring strategies, and a rollback mechanism. 5. Obtaining necessary approvals and documenting all decisions and actions. 6. Continuously evaluating the effectiveness of implemented solutions and adapting as needed. This systematic approach ensures that decisions are informed, defensible, and aligned with professional ethics and organizational objectives. Question 17. During the evaluation of a new NSX data center deployment process, a team identified that manual configuration reviews and post-deployment testing were leading to significant delays and occasional human errors. To optimize this process, what is the most effective and professionally responsible approach to enhance efficiency while maintaining security and compliance? Option A. Implement automated pre-deployment validation scripts that check configurations against predefined security baselines and compliance policies before any changes are applied, coupled with automated post-deployment verification. Option B. Bypass the configuration review entirely for urgent deployments, assuming that the vendor's default settings are secure and compliant. Option C. Focus solely on improving the speed of manual troubleshooting by encouraging engineers to implement fixes quickly without formal documentation or rollback plans. Option D. Expedite the manual configuration review process by reducing the number of checks performed and relying more heavily on network monitoring tools to detect issues after deployment. Correct answer is A. Implement automated pre-deployment validation scripts that check configurations against predefined security baselines and compliance policies before any changes are applied, coupled with automated post-deployment verification. Explanation. This scenario presents a common challenge in network operations, balancing the need for rapid deployment and troubleshooting with the imperative of maintaining a secure and compliant infrastructure. The professional challenge lies in identifying and implementing process optimizations that enhance efficiency without compromising the integrity of the NSX data center environment or violating established operational policies and potential regulatory requirements for data handling and network security. The correct approach, focusing on automated validation and pre-deployment checks, represents best professional practice because it embeds security and compliance directly into the deployment workflow. This proactive stance minimizes the risk of introducing misconfigurations that could lead to security vulnerabilities or operational disruptions. By leveraging automation, it ensures consistency, reduces human error, and provides an auditable trail of compliance checks, which is crucial for demonstrating adherence to internal policies and any relevant industry standards or regulations governing network infrastructure. This aligns with the principle of security by design and promotes a robust operational posture. An incorrect approach that bypasses or inadequately performs pre-deployment validation introduces significant regulatory and ethical risks. Such an action could be considered negligent if it leads to a security breach or non-compliance with data protection laws, as it demonstrates a disregard for established security protocols and due diligence. Ethically, it fails to uphold the responsibility to protect the organization's assets and data. Another incorrect approach, relying solely on post-deployment monitoring without proactive checks, is also professionally unsound. While monitoring is essential, it is a reactive measure. Failing to implement preventative controls means that vulnerabilities or misconfigurations are only identified after they have potentially caused harm or exposed the network. This can lead to significant remediation costs, reputational damage, and potential regulatory penalties for failing to maintain a secure environment. A third incorrect approach, prioritizing speed over thoroughness in troubleshooting without a documented rollback plan, is equally problematic. While rapid incident response is important, improvising solutions without a structured approach increases the likelihood of introducing further instability or security flaws. The absence of a rollback plan means that if the implemented fix exacerbates the issue, recovery becomes more complex and time-consuming, potentially leading to extended downtime and increased risk of data loss or unauthorized access. This demonstrates a lack of professional discipline and adherence to sound operational procedures. The professional decision-making process for similar situations should involve a risk-based assessment. Before implementing any process change or troubleshooting step, professionals should consider the potential impact on security, compliance, and operational stability. Leveraging automation for repetitive tasks, establishing clear change management procedures with rollback capabilities, and conducting thorough pre-deployment validation are fundamental to maintaining a secure and efficient NSX data center. Adherence to documented operational procedures and security policies is paramount, and any deviation should be justified, documented, and approved through appropriate channels. Question 18. Risk assessment procedures indicate that a critical financial transaction processing application, handling sensitive customer data, is currently protected by a broad, perimeter-based firewall policy within the NSX data center. Regulatory compliance mandates require granular network segmentation and strict access controls to prevent unauthorized data exfiltration and ensure auditability of all data access. Which of the following approaches best aligns with these regulatory requirements and best practices for securing such an application? Option A. Increase the capacity of the existing perimeter firewall and implement intrusion detection systems at the network edge to monitor for malicious traffic targeting the application. Option B. Implement microsegmentation using NSX distributed firewall rules to isolate the application tier from other network segments, enforcing strict ingress and egress policies based on the principle of least privilege, and enabling detailed logging for all traffic flows to and from the application. Option C. Disable certain NSX security features that are perceived to be impacting application performance, relying on endpoint security solutions for protection. Option D. Apply a generic security policy template to the application's network segment, assuming it covers common security threats without specific review against financial regulations. The correct answer is B. Implement microsegmentation using NSX distributed firewall rules to isolate the application tier from other network segments, enforcing strict ingress and egress policies based on the principle of least privilege, and enabling detailed logging for all traffic flows to and from the application. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the need for robust network security with the operational requirements of a critical business function. The core tension lies in the potential for security controls to inadvertently disrupt essential services, leading to business impact. The professional must navigate this by understanding the specific security posture required by regulatory frameworks and the operational dependencies of the application. The challenge is amplified by the need to ensure compliance with VMware NSX data center best practices and any applicable industry-specific regulations that mandate specific security controls or auditability. Correct approach analysis. The correct approach involves a thorough understanding of the regulatory compliance requirements that govern the specific industry and the data being processed by the application. This includes identifying any mandates for network segmentation, access control, or data encryption that NSX can enforce. By mapping these regulatory requirements to specific NSX security policies, such as distributed firewall rules, gateway firewall rules, or micro-segmentation strategies, the professional ensures that the security posture not only meets but exceeds compliance mandates. This proactive, compliance-driven design minimizes the risk of audit failures and associated penalties. Furthermore, it aligns with the principle of least privilege and defense in depth, which are foundational to secure network architecture and often implicitly or explicitly required by regulatory bodies. Incorrect approaches analysis. Implementing security policies solely based on perceived threats without a direct link to regulatory mandates is an incomplete approach. While threat mitigation is crucial, it may not satisfy specific compliance obligations, leaving the organization vulnerable to regulatory scrutiny and potential fines. This approach risks over-securing or under-securing specific aspects relative to what is legally required. Applying a generic security baseline without considering the specific data sensitivity and regulatory context of the application is also problematic. Regulatory frameworks often have tiered requirements based on the type of data handled, e.g., PI, financial data, health data. A one-size-fits-all approach may fail to address the unique compliance needs of the application, leading to non-compliance. Disabling security features to improve application performance without a documented risk assessment and explicit approval from compliance and security leadership is a significant regulatory and ethical failure. This action directly contravenes the principle of maintaining a secure environment as mandated by most regulatory frameworks. It bypasses established security controls, increasing the attack surface and the likelihood of a breach, which would have severe legal and financial repercussions. Professional reasoning. Professionals must adopt a risk-based, compliance-first methodology. This involves 1. Identifying all applicable regulatory frameworks and their specific requirements related to network security and data protection. 2. Conducting a thorough assessment of the application's data sensitivity and operational criticality. 3. Mapping regulatory requirements to specific NSX security controls and policies. 4. Designing and implementing security policies that demonstrably meet or exceed these requirements. 5. Documenting all security decisions, risk assessments, and exceptions, with clear justification and approval from relevant stakeholders, including compliance and legal teams. 6. Regularly reviewing and auditing security configurations against evolving regulatory landscapes and threat intelligence. Question 19. Process analysis reveals that a critical network service is experiencing intermittent failures, impacting user productivity. Initial investigation suggests a recent configuration change may be the root cause. The operations team is under significant pressure to restore full service immediately. What is the most professionally responsible course of action to address this incident while adhering to best practices for network operations and incident management? Option A. Roll back the recent configuration change to the last known stable state, followed by a thorough root cause analysis and retesting before reapplying any changes. Option B. Immediately deploy a hastily developed hotfix provided by a vendor, bypassing standard testing and documentation procedures to restore service as quickly as possible. Option C. Attempt to manually reconfigure individual network devices within the affected segment based on educated guesses, without a documented plan or rollback strategy. Option D. Isolate the affected network segment indefinitely until a permanent solution can be identified, accepting the ongoing service disruption. The correct answer is A. Roll back the recent configuration change to the last known stable state, followed by a thorough root cause analysis and retesting before reapplying any changes. Explanation. Scenario analysis. This scenario presents a common challenge in network operations, balancing the need for rapid incident response with the imperative to maintain compliance and operational integrity. Pressure to restore service quickly can lead to shortcuts that bypass established procedures, potentially introducing new risks or violating security policies. The professional challenge lies in making a decision that prioritizes both immediate service restoration and long-term adherence to established governance and security frameworks. This requires a nuanced understanding of the potential impact of each action on the overall security posture and operational stability. Correct approach analysis. The correct approach involves a controlled rollback to a known stable configuration. This represents best professional practice because it adheres to established change management and incident response protocols. By reverting to a previously validated state, the risk of introducing new, unknown issues is minimized. This methodical approach ensures that the network is restored to a predictable and secure baseline, which is crucial for maintaining compliance with operational standards and security policies. This aligns with the principle of least privilege and defense in depth, ensuring that any remediation action is well understood and its impact is predictable. Incorrect approach is analysis. One incorrect approach involves immediately applying a hotfix without proper testing or documentation. This is a regulatory and ethical failure because it bypasses critical change control processes, which are often mandated by internal policies and potentially by industry regulations, depending on the specific jurisdiction's compliance requirements for network infrastructure. Such an action introduces an unknown variable into the production environment, increasing the risk of further disruption or security vulnerabilities. It also fails to provide an auditable trail of the remediation steps taken, hindering post-incident analysis and future troubleshooting. Another incorrect approach is to isolate the affected segment indefinitely without a clear remediation plan. While this might seem like a safe option to prevent further spread, it is professionally unacceptable as it represents a failure to actively manage and resolve the incident. It can lead to prolonged service degradation for users and business operations, which is a failure to meet service-level objectives. Ethically, it demonstrates a lack of proactive problem-solving and can be seen as neglecting the responsibility to restore full functionality in a timely and secure manner. It also fails to address the root cause of the issue, leaving the network vulnerable to recurrence. Professional reasoning. Professionals should approach such situations by first prioritizing containment and assessment. This involves understanding the scope and impact of the incident. Following containment, the decision-making process should involve evaluating remediation options against established change management procedures, risk assessment frameworks, and security policies. The primary goal is to restore service while minimizing risk and maintaining compliance. This requires clear communication with stakeholders, thorough documentation of all actions, and a commitment to post-incident review to prevent future occurrences. The decision should always favor a controlled, documented, and validated approach over a hasty, undocumented fix. Question 20. Regulatory review indicates that a critical infrastructure organization is planning to implement VMware NSX distributed firewall rules for enhanced microsegmentation across its production environment. The primary objective is to strengthen data protection and access control. Given the urgency to enhance security posture, what is the most professionally responsible approach to deploying these new firewall rules? Option A. Deploy the distributed firewall rules to all production workloads simultaneously to achieve immediate and comprehensive security coverage. Option B. Implement a phased rollout strategy, beginning with a pilot group of non-production workloads, followed by a limited deployment to production workloads with comprehensive testing and rollback plans. Option C. Prioritize the security benefits of microsegmentation and deploy the rules directly to all production workloads, assuming minimal operational impact due to the granular nature of the rules. Option D. Deploy the distributed firewall rules only to production workloads that are identified as high risk, without extensive pre-deployment testing, to expedite the security enhancement. The correct answer is A. Deploy the distributed firewall rules to all production workloads simultaneously to achieve immediate and comprehensive security coverage. Explanation. Scenario analysis. This scenario presents a common challenge in network security architecture, where the implementation of a new security control, specifically distributed firewall rules for microsegmentation, must be balanced against operational efficiency and compliance with established security policies. The challenge lies in ensuring that the new rules do not inadvertently disrupt critical business operations or create new vulnerabilities, while also meeting the stringent requirements for data protection and access control mandated by regulatory frameworks. The pressure to deploy quickly can lead to rushed decisions that overlook potential negative impacts. Correct approach analysis. The correct approach involves a phased rollout and rigorous testing strategy. This aligns with best practices for implementing significant network security changes. By deploying the distributed firewall rules to a limited set of non-production workloads first, the team can validate their effectiveness and identify any unintended consequences in a controlled environment. Subsequent testing on a small subset of production workloads, with rollback plans in place, further mitigates risk. This iterative approach ensures that the security posture is enhanced without compromising service availability or introducing new compliance risks. This methodology is implicitly supported by general IT governance principles that emphasize risk management and change control, which are foundational to regulatory compliance and data security. Incorrect approaches analysis. Implementing the distributed firewall rules across all workloads simultaneously without prior testing is a direct violation of prudent change management and risk assessment principles. This approach significantly increases the likelihood of widespread service disruption and potential data access issues, which could lead to non-compliance with data protection regulations. Deploying the rules only to production workloads without any pre-deployment testing or a phased approach introduces an unacceptable level of risk. This bypasses essential validation steps, making it difficult to predict or contain the impact of any misconfigurations or rule conflicts, thereby jeopardizing operational continuity and potentially leading to data breaches or unauthorized access, both of which are regulatory failures. Focusing solely on the security benefits of microsegmentation without considering the operational impact and the need for validation demonstrates a failure to adopt a holistic risk management approach. This narrow focus can lead to the implementation of controls that are technically sound but practically unworkable or detrimental to business operations, ultimately undermining the overall security and compliance objectives. Professional reasoning. Professionals must adopt a risk-based approach to network security changes. This involves thorough planning, impact assessment, phased implementation, and continuous monitoring for deploying any new security control, especially one that affects network traffic at a granular level like distributed firewalls. A comprehensive understanding of the existing environment, potential interdependencies, and business criticality of affected systems is paramount. The decision-making process should prioritize minimizing disruption while maximizing security and compliance. This includes establishing clear testing protocols, defining rollback procedures, and ensuring adequate stakeholder communication throughout the deployment lifecycle.